Hi, in this video I am discussing Edexcel IAL January 2022 Unit 4 paper. I will discuss other papers also. If you subscribe this channel, you will get the notifications when those videos are uploaded. Okay, the first question, MCQ, January 2022, Unit 4, January 2022, Unit 4, paper, Edexcel IAL. So, O178 is an isotope of oxygen. You know, this is O-level type question. So, this is the mass number, this is the atomic number, or we can say for the nucleus, this is the charge, this is the baryon number. Either way, we can interpret it. The question is, number of nucleons and number of neutrons are shown on a table. We need to select the proper answer. We know this is the number of nucleons, this is the number of protons. So number of neutrons will be 17 minus 8, that will be 9. So the correct answer, D. Question number 1, correct answer, D. Question number 2, which row in the table gives the charge and mass of an antiproton? So the mass and charge of a proton, actually mass of a proton is given in the data sheet. We know the mass of a proton. Question number 2, mass of a proton is 1.67 10 to the power minus 20, 1.16 10 to the power minus, 1.67 10 to the power minus 27 kilogram. That's given in the data sheet. Mass of antiproton also will be the same. You know, any particle and its own antiparticle will have the same mass. But charge of a proton, we know that 1 plus 1.6 10 to the power minus 19 Coulomb. So charge of an antiproton will be negative minus 1.6 10 to the power minus 19 Coulomb is the charge of antiproton. Charge of proton and charge of antiproton will be the mass of proton and mass of antiproton will be the same. So that will be 1.67 10 to the power minus 27, and charge of antiproton minus 1.6 10 to the power minus 19 Coulomb. So the correct answer, D. Question number 2, correct answer, D. Okay, question number 3 and 4 based on a diagram related to collision of two trolleys. So this is a diagram given. Before collision, trolley Y is at rest, trolley X is moving with a momentum, not the velocity, momentum of 0.5 Newton second. Newton second and kilogram meter per second, both are the same units. So after collision, they merge together, they join together and move at a velocity of 1 meter per second. So the question number 3, which of the following is the kinetic energy of trolley X before collision? So this is trolley X. So kinetic energy of trolley X, we can say the equation kinetic energy equal P squared over 2M. Mass given, mass of each trolley is 0.25. So the kinetic energy of trolley X before collision is 0.5 joule. Correct answer, C. Question number 3, correct answer, C. Question number 4, a table is given about momentum and elastic or inelastic collision. So which quantity conserved? So if you think about the total momentum before collision and total momentum after collision, I'll do it here. Before collision, I'll put B dot C dot before collision. This is at rest, so 0.5. Final total momentum or after collision, the mass is given 0.25. So total mass 0.25 into 2 times velocity 0.5 Newton second. So momentum is conserved in this collision. So we need to think about the total kinetic energy after collision. half times mass times v squared, that is half into mass is 2 times 0.25, that is 0.5 into 1 squared, that is 0.25 joules. So total kinetic energy after collision is 0.25 joules. Total kinetic energy before collision, its kinetic energy before collision is 0. So total kinetic energy before collision is 0.5. Total kinetic energy after collision is 0.25. So kinetic energy is not conserved in elastic collision. Momentum is conserved. So answer B. Momentum conserved. Elastic or inelastic collision, it is inelastic collision. So question number 4, answer B. Okay, again, question 5 and question 6 depends on the same diagram. So there is an electron emitted from the warm coil or heated coil, and it's passing through a gap between two parallel plates and hitting the screen. So the question number 5, electrons are released from the heated metal filament. Which of the following is the name for this process? We know thermionic emission. So when certain metals such as certain metals are heated, so tungsten is heated mostly, the atoms absorb the thermal energy and they will vibrate. When they vibrate, the electron will be released. So this process is called thermionic emission. So question number 5, correct answer D. Okay, question number 6, when a potential difference is applied across the parallel metal plates, the electrons are deflected. Which of the following changes would decrease the deflection of the electrons? So you know the reason for deflection is the electrostatic force acting on the electron when it passing through the region between the plates. There will be electrostatic force acting in this direction. We know that electrostatic force is given by F equal QE. Q is the charge of the electron. Q into, parallel plates, it's given by E equal V over D. So if you want to reduce the deflection, the upward acceleration should be reduced or upward force should be reduced. So to reduce the force, you have to increase the distance between the parallel plates, or voltage across the parallel plates should be reduced, or distance between the parallel plates should be increased. You should increase the distance between the parallel plate or reduce the voltage across the parallel plates. That will give lower force, then the deflection will become smaller. So the correct answer, increasing the distance between the plates, is the correct answer. Answer B. So the correct answer is B. Okay, question number 7. This diagram is given. A square coil PQRS has sides of length L. There is a clockwise current. So there's a clockwise current in the coil as shown. The plane of the coil is parallel to the magnetic field of magnetic flux density. So the plane is parallel to the magnetic field, which is directed towards right. Which row of the table is correct? So sides are given PQ, QR, RS, SP, and the magnetic force is given. If you use the Fleming's left hand rule, there won't be any force on the sides PQ and RS because the direction of the current and the direction of the magnetic field are parallel. The directions could be different, opposite here. The direction is opposite, but they are parallel. So you can't use the Fleming's left hand rule because they are the direction of the magnetic field and the direction of a current should be perpendicular to each other. So there is no force on PQ, no force on RS. So what's the force on SP? If you use the Fleming's left hand rule, magnetic field is towards right. The current is upward direction. So the force on SP will be into the board. The direction of the force here will be into the board. So here the force will be out of the board if you use the Fleming's left hand rule. So the correct answer here, you can read all. So the correct answer is A. PQ, there is no force. So correct answer A. The second one, QR, zero force, that is wrong. There is force which is directed out of the page. RS, BIL into the page. Actually RS, there is no force. So that statement also wrong. SP, there is force out of the page, is wrong, into the page. So the correct answer for question number 7 is A. Okay, question number 8 about Rutherford Alpha particle scattering experiment. Which of the following could not be the concluded from the results of these experiments? So the nucleus is charged is correct. It was proposed by using one of the, most of the alpha particle went straight, the three observations and the relevant conclusions. So nucleus is charged is one of the conclusion. That is correct. We need answer following could not be the conclusion. So answer A is the correct statement. So it's not the answer here. The statement B, the nucleus contains most of the mass of the atom. Yes, that is correct. That is all the books give that as a conclusion. So that also a correct statement, not the answer for question number 8. So statement C, the nucleus contains neutrons and protons. Actually, Rutherford alpha particle scattering experiment conclusion never says about protons or neutrons. So that statement is wrong. So correct answer for question number 8, C. Question number 8, correct answer, C. Okay, question number 9. The charged particle is accelerated in a spiral path in a cyclotron. Which of the following changes would increase the amount of energy transferred to the particle as it travels through 360 degrees? So when it completes one orbit, right? So in which of those four different changes it can get more energy? You know the energy equation for the energy, we can say gaining kinetic energy is equal to work done by the electric potential that is given by QV, where Q is the charge of the particle being accelerated and V is the potential difference applied across the D. So V is the potential difference, means that is the peak voltage. Normally they give square waves. So the sinusoidal wave or square wave, mostly it's square wave. So the square wave means the voltage is this one. So this is the peak voltage. This is the V. So the peak voltage, right? So here the first one, increasing the distance between the Ds. So it has no effect. So you can see gaining kinetic energy equal QV. So it does not depend on the distance between the Ds. It can sometimes give trouble in the time period. But here normally we keep very narrow distance. So QV does not depend on the D. Increasing the frequency of the potential difference across these, that has no effect frequency. So the frequency should match with the period of the frequency of circular motion of the charged particle. You know the time period of the particle T equal 2 pi m over VQ. So frequency should be VQ over 2 pi m. So you can't choose any frequency randomly. The frequency must be this one. If the charge of the particle is Q and mass of the particle is M, this must be the frequency of the AC signal. So the statement B is also not correct. Statement C, increasing the strength of the magnetic field within the disk. Actually, strength of the magnetic field decides the radius of orbit. So R equal P over BQ. If you increase the B, the radius will decrease. So that is an advantage. By increasing the B, you can reduce the R, means you can keep the particle inside the cyclotron for longer time. Say for example, if you use a lower B, when it completes one orbit, the radius could become larger. So it will leave the cyclotron very quickly when it completes only few circular paths. But if you increase the B, you can keep it for longer time inside the cyclotron. That will increase the energy. But here the question is about when it completes one full orbit. The increase of B will cause the particle to move inside the cyclotron for several rotations. That also will increase the energy, but here the question is about one full orbit. So no point of increasing the B. So the correct answer, increasing the maximum potential difference across the D. So increasing the maximum potential difference across the V, that means by increasing the V, we can increase the kinetic energy when it completes one full orbit. Once again, I'm telling, when I'm increasing the B, there is advantage. It can reduce the R. So the particle can rotate inside the D for several times. It can rotate several times before it comes out of the cyclotron. But here the question is about one full rotation. So this increase in V has no effect. That's not the answer for this question. So the answer is increasing the V will increase the energy of the particle. Question number 10. A website states the radius of the orbit of the moon around the earth is increasing by a small amount each year. However, the time period of the orbit remains constant. So they are saying it. Time period remains constant. They are saying accept it, right? Which of row in the table correct if the statement is correct? So we know the equation. So omega equal to pi over t. Omega equal to pi over t. So if the time period remains constant, then angular speed will remain the same, no change. So what will happen to the speed? Speed is equal to r omega. So the moon is moving away from us, means r will increase. Omega remains the same because time period remains the same. So the speed will increase. Speed will increase. This remains the same, no change. So the correct answer B, angular velocity remains the same, constant, and speed will increase. Correct answer for question number 10, B. Okay, now section B, question number 11. The diagram represents a negative point charge. Draw field lines to show the electric field around the charge. So, you know, a point charge will create radial field. How do we define the direction of the electric field? Imagine if we keep a positive test charge, the direction of the force experienced by the positive test charge indicates the direction of the field at that point. So, it's a negative point charge. If I keep a positive test charge here, it will experience a force towards the negative point charge, attractive force. So the electric field will be towards it. Same if I keep a positive test charge, it will experience towards it. So the electric field lines are towards it. You can draw 4 lines or symmetrically 8 lines is enough. It's a negative point charge. Okay, question number 12. A helicopter can hover in a fixed position as shown. The helicopter blades move air vertically downwards. Explain how this enables the helicopter to maintain a constant height above the ground. Okay, you know, when the blades rotate, they push the air downwards by exerting force on them. So when the force is exerted on the blades downwards, when the force is exerted on the air particles downwards by the blades, there will be, according to Newton's third law, there will be force exerted by the air particles on the blades in upward direction. Or you can say the air particles are gaining momentum in downward direction. So according to Newton's third law, the air particles will exert same magnitude of force in upward direction. The reason the air particles are gaining momentum downward direction. So change in momentum over time is the force experienced by the air particle in downward direction. So there will be a rate of change of momentum for the air particles in downward direction. According to Newton's third law, the air particles will exert the same magnitude of force on the blades in upward direction. So if the total force exerted by the air particles on the blades in upward direction is equal to weight of the total weight of the helicopter, then the resultant force acting on the helicopter will be equal to 0 and the helicopter will be at rest, or the helicopter will be able to maintain the same height because there is no resultant force on it. Answer for the question number 12 is shown on the screen. Okay, next question number 13. these diagrams are given, right? The surface of a balloon can become charged by rubbing it against clothing. The charge on the surface of the balloon can be assumed to act as if it was concentrated at the center, concentrated at the balloon's center. Two balloons are suspended by cotton thread so that they just touch each other as shown in the diagram 1. This is the diagram 1. The two balloons are then given equal negative charge and repel as shown in figure 2. The dots, so the dots represents the center, show that the force of repulsion between the balloons in the diagram 2 is about 1 into 10 to the power minus 3 Newton. Mass of each balloon is 1.1 gram. Okay, so here only thing we need to find the angle theta. Okay, so little bit confusion because in this question it's not mentioned the string is vertical when the two balloons are touching each other. The strings are in vertical direction. It's not mentioned, but we have to take like that. That means the point where the string is attached to the support or roof, wherever it is, that is exactly above the center of the balloon, or same way this point also exactly above the center of the balloon. So the distance between center to center is 0.21 meter, means here the distance between these 2 points where they are, the strings are connected to the roof, also 0.21 meters when we take the strings are in vertical position. Okay, so now when you give the same amount of charge, both balloons have the same mass. So same amount of charge, you know, according to Newton's third law, they will experience the same magnitude of electrostatic force F equal K Q1 Q2 R square, but Q is the same. Since they have same mass, the angle of deflection will be the same. If the mass is different, the angle of deflection will be different. But both balloons have the same mass, means they are going to have the same amount of deflection from their initial position. So we will see the center has deflected from the initial position. So this is the initial position. This is the initial position of the second balloon. I can name this as X and this as Y. So initially the center of the X is here. Initially the center of Y was here. Now they have deflected. The center of the X has come to this position. Center of the Y has come to this position, means these are the initial position of the center. So these will be 0.21. Both balloons will shift through the same distance because they have same mass. So the distance they shift is D and D. And the distance between the two centers are given in the second diagram, which is 0.47 meters. And we assume that all these centers, you know, initially these two centers, when you connect 2 points, they will form a straight line. We know that geometry. But you know, when something is moved up, so imagine there is a ball initially at this position, and when you pull it a little bit up here, the center of the ball will go above the initial position. But we assume here also the angle is very small, so still the center is at the same position. We'll take it like that. Okay, so in that way we can say here 0.21 plus D is equal to 0.47 meters. So 2D is equal to 0.47 minus 0.21. So D will be equal to, divide this value by 2, you will get 0.13 meter. So I know the distance D. I need to find the theta. So sine theta is equal to opposite D, which is 0.13 over hypotenuse, that is 1.22. Find the theta. That's going to be 6.12 degree. Okay, so I know the angle theta. So only thing I need to find the force acting. The first part, we need to find the force acting on both balloons. So I can think about the balloon X. It has weight vertically downwards, mg. The tension is acting along this direction, T. That makes an angle theta. I already found the angle theta. I know that 6.12. There is an electrostatic force Fe. So I need to find the electrostatic force. So I can say, if I resolve it vertically, T cos theta equal mg. Horizontally, T sin theta equal Fe. Fe is the electrostatic force, Fe. So divide each other. Equation 1 equation 2, divide 2 by 1, t sine theta over t cos theta equal to Fe over mg. T and t will get cancelled, sine over cos tan theta equal Fe over mg. Substitute. We know the theta 6.12 degree. So Fe will be equal to mg cos multiply. Mass is given. That is, I can say that is t cos 61. Yes. Fe we know we need to find it. So tan mg mass is given 1.1 grams. So 1.1 10 to the power minus 3 into 9.81 into tan 6.12. Solve it, you will get the Fa. So that will be 1.15 or 1.15 10 to the power minus 3 Newton. That's the answer for electrostatic repulsive force. Okay, it's 1.16, 1.157, so 1.16. Okay, 1.16 10 to the power minus 3 Newton. Okay, second part, question number 13. Show that the charge on each balloon is about 2 into 10 to the power minus 7. So we can say the electrostatic force is equal to K Q1 Q2 over R squared. Both carry same magnitude of charge. And we know the electrostatic force 1.16 10 to the power minus 3 equal 8.99 10 to the power 9. Q times Q, same charge. So Q times Q, Q squared over R squared, 0.47 squared. So find the value of Q. That will be 1.69 10 to the power minus 7 Coulomb. Approximately approximately we can say 2 into 10 to the power minus 7 Coulomb. Okay, so B part, one balloon is removed and the remaining balloon returns to its original position. Calculate the electric potential at a distance of 0.3 meter from the center of the remaining balloon. So, you know, we can assume, already it's mentioned, we can assume the charge distributed on the surface is concentrated at the center. Gauss law actually. We can assume the whole charge is concentrated at the center. So, the equation for the electric potential is given by V equal KQ over R. And we should use the sign of the charge when we are using this equation for electric potential created by a point charge, the radial field. So 8.99 10 to the power 9 into charge is a negative charge. They already mentioned that. So magnitude, we say 2 into 10 to the minus 7 or 1.69 10 to the minus 7 is the magnitude. But here it's a negative charge. So we should include that minus 1.69 10 to the power minus 7 over the distance at a distance of 0.3. So solve it, you will get the electric potential, you will get 5094 or something, 5090 odd, 5064 volt. Okay, question 14, a circuit diagram is given with a capacitor. A student built the circuit shown the capacitor was initially uncharged. You can see that both the ammeters A1 and A2 are connected in series. No junction, no branch. So we know it's series connection. And the graph for charging current is given. You know it's an exponential decay. Determine whether the initial value of the current on the graph is consistent with the value stated on the circuit diagram. So if you see the graph, the initial value is 0.15 milliampere. We know we are going to calculate and check whether the value shown on the graph as the initial current on the graph, you can say it's shown as 0.15 milliampere. We are going to calculate and check whether that value is correct. So we know that when circuit is connected, initially capacitor has no charge. So that means the voltage across the capacitor is equal to 0. We know that since the resistor and capacitors are connected in series, at any instant, say this is the resistor, ammeters have no resistance. So the voltage across the capacitor, if I say VC, voltage across the resistor VR, the EMF of the battery or power supply is epsilon, and the current flow at an instant I, if I say the current I, we know that according to Kirchhoff's second law, at any instant we can write the equation EMF is equal to I VR plus VC. So since initially there is no charge in the capacitor, Q is equal to 0 for the capacitor. So according to Q equals CV, the voltage of the capacitor will be equal to 0. So EMF is equal to VR when T equals 0 or initially. But we know VR equal IR. So I naught R, I can say I naught is going to be EMF over R. EMF is given as 5 volt. R is 33 kilo ohms, 33,000. Solve it. You will get the initial current, that is 1.52 10 to the power minus 4 ampere. If you convert to milliampere, multiplied by 1000, you will get 1.52 10 to the power minus 4 into 1000 milliampere, that is 0.15 milliampere. So consistent, we can say it is consistent with the graph. You can write that it is consistent with the graph value shown on the graph. That's the answer for A part. B part, explain how the current on ammeter A2 would vary over the same time interval. So they have given a graph for the ammeter A1. Actually A1 and A2 are connected in series. So the variation of A2 also will be same as the variation of A1. You know that O-level knowledge. You know A1 and A2 are connected in series means the current flow in the circuit, there won't be any current flow between the plates, but in the external circuit, the current flow is due to the transfer of electron from one plate to the other plate during the charging process. Same charge will flow through both ammeter A1 and ammeter A2. That is, rate of flow of charge will be the same. So the variation of current recorded by A2 will be same as A1. So the answer, you can say both A1 and A2 are connected in series. Therefore, the current flow will be the same. The charge flow, rate of flow of charge is the same. So the variation of A2 is same as the variation of A1. I don't need to write that answer on the board. Right. Part C, determine the capacitance of the capacitor. So you can do that in many different ways. You can find the graph is given. So you can see the graph, it's an exponential graph. Current milliampere against time. So it's an exponential graph. You can follow many different ways. You can find the initial current. We know that 0.15 milliampere. We know that. You can find the half-life and you can use T half equal RCLN2, or you can find the time taken to drop to 37%, that is time constant. Any method you can follow, but I am doing because easy to get the values, the graph. So I am using the equations B part, the C part. I am using the equation I equal I naught e to the power minus T over RC. So when you see the 3 seconds, when you see the time for 3 seconds, the value recorded on the graph is a very clear value, 0.1 milliampere. So I thought of following this method, but you can do other methods also, half-life or time constant method. So here, if I consider 3 seconds, the current is 0.1 milliamperes, initially 0.15 e to the power 3 over 3 seconds RC. You can solve it. You know how to solve that by using ln method. E to the power 3 over RC is equal to 0.15 over 0.1. Take both sides ln and find the RC. So the value of RC will be 7.40 seconds. Find the value of C. 7.40 over R is 33,000. Yeah, 33,000. You will get the capacitance 2.24 10 to the power minus 4 farad, or you can say 224 multiplied by 10 to the power 6 to get the microfarad, 224 microfarad. That's the answer for question 14, part C. Okay, part D, determine the charge stored on the capacitor after 30 seconds. At 30 seconds, what will be the charge stored in it? So, you know, you can see the graph. So, at 30 seconds, you can see the current flow becomes almost zero. That means capacitor is fully charged. When the capacitor is fully charged, the voltage across the capacitor will be equal to EMF. No current flow. So if there is no current flow, there is no voltage across the resistor. So all the voltage applied by the power supply will be across the capacitor. So the voltage across the capacitor will be equal to 5 volt. We need to find the charge stored in it. So question D part, Q equal CV. We know the capacitance, we already found it, 224 microfarad, 10 to the power minus 6 into 5. So you will get 1.12 10 to the power minus 3 Coulomb. E part, determine the maximum energy stored in the capacitor. Maximum energy stored when the capacitor has the maximum voltage across it or maximum charge in it. So I can say E max is equal to, maximum energy is equal to half QV I can use, or half CV squared, half CV max squared. So half C 224 10 to the power minus 6 5 squared. Solve it, you'll get the maximum energy. That will be 2.80 10 to the power minus 3 joules. Okay, question number 15. A poi ball is attached to a person's hand by a cord. A child makes the poi ball undergo circular motion in a vertical plane as shown in the photograph. The ball moves clockwise in a circular radius R, center O. With a constant speed v. The diagram shows two positions A and B of the ball. Derive the equation A equal V squared, or you can find these derivations everywhere in all books, but I'll derive it again. So here actually when we derive, we take two positions. Actually this equation A equal V squared over R, we can use it even when the speed is not constant. At an instant we can use it. Say for example, when something is moved on a vertical circular plane, say for example a small ball is attached to a string initially held in vertical position. Here it's held or attached to a nail on a wall. The string is held in horizontal position, and when you release the ball, it will move on a vertical plane. You know the speed will change continuously, the speed will increase. At any instant t, you can use the equation A equal V squared over R, where V is the instantaneous speed, that is speed at that instant. R is the radius of the circular path, that will be the length of the string. Okay, so here this is not an average acceleration, it's an instantaneous acceleration. So to derive the instantaneous acceleration, we need 2 points. Those are very closer to each other. That means we take A and B are two different points, but they are very, very closer to each other. Means delta theta almost equal to 0. So here remember that delta theta almost equal to 0 but not equal to 0. Almost equal to 0, not equal to 0. The same diagram, I drew it enlarged diagram. Looks like A and B are far apart, but actually A and B are very closer points. They are very closer to each other, but it's an enlarged diagram where delta theta is almost equal to 0. So if delta theta almost equal to 0 means A and B are almost the same points, but not the same points, very closer to each other. Okay, so the length along the arc, that is delta S, I can say the length is delta S, that is equal to R delta theta. You know that in a geometry, you know that the length, the segment is given by R delta theta. Okay, so in this quadrilateral, this AB, you can say AB, this I can say N, BO in this quadrilateral. You know that this is delta theta. So the velocity is along the tangent. So this is 90 degree, this is 90 degree. So the total addition of the internal angles will be equal to 360 degrees. So this angle should be 180 minus delta theta, because these two are 90 plus 90, 180. So this angle will be 180 minus delta theta. This is a straight line. So this will be delta theta. Okay, so the angle between the two velocities, delta theta. So here they are saying it's moving at constant speed, because we can take, even if they are not moving at constant speed, as I explained earlier, when it is moving in vertical circular path, we can assume the VB, even when the velocity is changing throughout the motion in vertical plane, since we are considering point A and point B very closer to each other, we can neglect the change in magnitude. We can say modulus of velocity at point A almost equal to modulus of velocity at point B. So here I can say VA, the magnitude, is equal to VB at the point B. I can call it as V, the velocity, V, the speed, V. V is the speed, the magnitude of the velocities at point A and B. Those are very closer to each other. So we know that delta S equal R delta theta. Okay, so we need to draw a vector diagram. So I know that change in velocity, delta V is equal to final velocity VB minus VA. So I can say V is equal to VA plus delta V. Okay, so I know the direction of these two velocities, VB and VA. If I draw a vector diagram, VA along this diagram direction, the magnitude is equal to V, VA, this one, that is equal to V. VB, I know that going to be the resultant vector. When I add delta V with this, I should get the VB. VB is along this direction. Same length, because magnitude is the same. So the delta V will be along this direction. So the angle between VA and VB, this is VB, I can call VB equal V. The magnitude is the same because A and B are very closer points. So the angle between VA and VB is delta theta. So this angle between VA and VB, this is delta theta. So this VA, which is equal to V, VB, which is equal to V. So this delta V could be written as something like a segment, but I wrote here AB, looks like curve, but if when A and B are very close, I can take AB as a straight line. Same way, delta S, this delta S, I wrote it as R into delta theta. Same way I can write delta V is equal to, in this triangle, velocity triangle, delta V is equal to V delta theta. V means the length of this line, same as length of this line, that is V, this also V, angle delta theta. So delta V is equal to V delta theta. Delta S is equal to R delta theta. So from this I can write delta theta is equal to delta V over V. From this I can write delta theta is equal to delta S over R. So delta theta same, therefore right side is the same. So I can say delta V over V equal delta S over R. We need to find the acceleration, that is delta V, change in velocity over time. So we'll write delta V equal delta S times V over R cross multiply delta S V over R divided by time. The time taken to travel from A to B, let it be delta T. Delta V over delta T is equal to delta S over delta T. Divide both sides by the time taken to travel from A to B, which is very closer points. Both are closer points, into V over R. Delta V over delta T, change in velocity over time taken, is the acceleration. So acceleration, here I can continue here. Acceleration delta V over delta T, I will continue here. Acceleration is equal to delta S over T. The time taken to travel from A to B is delta T. The distance is delta S, but they are very closer points, so they are almost same points. So the speed will be given by delta S over delta T V into V over R, that is V squared over R. Okay, part B. The ball completes 1.3 revolutions per second. Calculate the acceleration of the ball. Radius of the motion is given. So it's not a big issue. We need to find the acceleration. So omega, we can find that V part omega is equal to change in central angle over time taken. So it completes 1.3 revolutions. So when it completes one revolution, change in central angle will be 2 pi radian. So this will be 2 pi times 1.3 over time taken is 1 second. So this much of radian per second. That will be, so you can find that 0. Yeah, I'll continue that. A equal, the acceleration is the question, A equal R omega squared. So radius is given as 0.58. Omega, this much, 2 pi into 1.3 all things squared. So now solve it. 38.7 meter per second squared. Okay, C part, the child comments that as the ball goes round the circle, so the child is rotating the ball in vertical circular motion, so goes round the circle with a constant speed. Practically not easy to rotate in vertical plane at constant speed, it's very difficult. Anyway, but the question is saying that we'll accept it, constant speed. The size of the force on his hand changes. You can rotate in vertical plane if the, instead of string, if it is connected like a rigid rod, then you can rotate in vertical plane easily at constant speed. But if the ball is attached to a string, very difficult to rotate in vertical plane at constant speed, because when the ball moves from higher position to lower position, anyway the speed will increase. But the question is saying it's moving at constant speed, we'll accept it. Discuss whether this comment is correct. Okay, so the student is saying, the child is saying that the force on his hand, you know, that is the tension. That is the tension acting on the string. The tension acting on the string will be exerted on his hand. The force acting on the hand changes when it moves on a circular path in vertical plane. So we need to discuss whether it's right or wrong. We'll first think about the vertical motion, vertical circular motion. When the ball is at the highest point, we can consider at the lowest point and one of the sides when it is a moving vertical circular motion. So I can call these positions X, this as Y, and this as Z. When the, you know, the centripetal force is the resultant force towards the center of the circular path. When it is at X, The forces acting on it are the weight will act towards the center. Center is O. So the weight will act towards the center, O. And the tension also will act towards the center. So the centripetal force acting on the ball is the resultant force towards the center. That is centripetal force is T plus mg. That is equal to mv squared over r. He is moving it at constant speed. The question says if the ball is rotated at constant speed, so mv squared over r, that is the centripetal force is constant. So T plus mg is the resultant force towards the center. So T will be equal to mv squared over r minus mg. That will be the lowest tension. That means when the ball is at the highest position, the tension will be the lowest. I can say T minimum is equal to mv squared over r minus mg, that is at x. So at y, when I consider at y, the ball, the resultant force acting on the ball towards the center is the centripetal force. So if I draw the free body force diagram, the weight will act downwards, the tension will act upwards towards the center. Center is here, O. So the resultant force towards the center of the circular path is the centripetal force. So F is going to be towards the center, upward direction. That is T minus mg is equal to mv squared over r. That is constant because ball is rotated or moved at constant speed. So T is going to be mv squared over r plus mg. So that is going to be the maximum value. So T max equal mv squared over r plus mg. That is the maximum at y. So that will be the maximum value. At z, when I consider at z, so the only force acting towards the center, so if I draw the free body force diagram at z, the weight will act vertically downwards and the tension will towards the center O. So the centripetal force here is the tension. So I can say the centripetal force, vertical force, which is weight, has no horizontal component. When you resolve a vector through 90 degrees, it won't have components. So weight has no component in horizontal direction. So the centripetal force is the tension, that is equal to mv squared over r. So T will be mv squared over r. So that is somewhere between minimum and maximum. So the child is correct. So you can do like this. You can show a small diagram rather than writing in words too much. You can show the three different positions, the lowest position, the horizontal position, and the highest position. You can work it out. First, better define what is centripetal force. Better define centripetal force. The resultant force towards the center of the circular path is defined as the centripetal force, which is given by mv squared over r. Since v is constant, the centripetal force is constant. You can say that. So here, for your understanding, I wrote a lot of sentences, but in the exam you can reduce the number of lines. So resultant force T plus mg at the highest position, both forces are downwards, tension and weight, equal to mv squared over r. So find the T, make the T subject mv squared over r minus mg. Same way at the lowest position, mv squared r plus mg at the horizontal position. Then you should say the force acting on the hand of the child is the tension. Force acting on the hand of the child is tension. Since the tension is varying, the force acting on the hand is varying. The statement is correct, or the child is correct. You have to tell that answer. I'll write the answer now on the board. Okay, question 16. The diagram shows particle trapped in a detector. A negative K meson collided with a stationary proton. An omega baryon and a positive K meson were produced after the impact. So the track is shown. Explain the process that enables a particle detector to detect charged particle. 2 marks question. You can see how the how the particle detectors detect the charged particles. You know, when charged particles moves through the medium of the particle detectors, they will ionize the atoms of the medium, and due to the ionization, they produce track. If it is a bubble chamber, when a charged particle moves through the liquid hydrogen, they ionize the liquid hydrogen, transfer the energy, and boil the liquid hydrogen only along their path. So the liquid hydrogen will be boiled only along the path of the particle, and tiny bubbles will be formed. In a cloud chamber, you know, they ionize, and the along the ions, the alcohol vapor will be condensed and it forms a white track. In spark chambers, they ionize, but they don't form a track. It cannot be photographed. So along the path, they produce spark, and by detecting the spark, the computer screen will draw the track. Anyway, but basically the principle, what happens in all type of particle detectors, the charged particles will ionize the medium, the atoms of the medium, and transfer the energy, and by using the ionization only along the path, track will be formed. Okay, B part, describe the structure of a baryon and meson. So I don't need to write, you know, baryon consists of 3 quarks. Baryon consists of 3 quarks, or baryon is made of 3 quarks. Meson is made of a quark and an antiquark. 1 quark and 1 antiquark. Meson consists of 1 quark and 1 antiquark. That's enough, right? Okay, so B part, second part, page number 16. Magnetic field acts in the detector. State the direction of the magnetic field. So you can see the track of the K plus. So this is K minus is straight line. Then K omega is going this way, a slight curve, but it looks like a straight line. But you can see this is omega particle, and the K plus is shown with a reasonably larger curve. This is K plus. So if the particle is moving this direction, you know, it's a positively charged particle. You know, the direction of the current flow produced by the motion of the charged particle will be same as the direction of velocity. We know the particle is moving from left to right. So the current flow due to the motion of K plus is also this direction. This is the direction of the current. And we know the force acting on the center of the curve path, or center of the curvature. So force is acting this direction, because you know, when a particle moves in a magnetic field, charged particle moves in a magnetic field, it will move on a circular path if the magnetic field is applied perpendicular to the direction of velocity of the particle. So the force will act towards the center of the curvature. So the force is acting towards the center. So velocity is this direction towards right. So positive charge particle, current flow also the same. If it is a negatively charged particle, current flow will be opposite to the direction of motion of the charged particle. But K plus is a positive particle. So now I can use the Fleming's left hand rule. I know the direction of the force. The thumb will indicate the direction of the force. Current flow is towards right. That's the second finger. And you know, the index finger is pointing into the board. So the direction of the magnetic field into the board. So direction of the magnetic field into the board for the answer for the B part, second part, magnetic field into the board. Okay, so question number 16, B part, third part. Deduce the charge and baryon number of the omega part. We will think about the reaction equation. So that's easy. We know the track is shown like K minus is hitting a stationary proton. After collision, it's forming omega particle and K plus. So I don't need this diagram for this answer, but I just showed it. So B part, third part, I can say K minus plus P gives omega plus K plus. Right, so we'll check for the charge and baryon number. You know, during all particle interactions, total mass energy must be conserved. Mass alone will not be conserved. I'll explain in the next part. Mass alone will not be conserved. Energy alone will not be conserved. Only total mass energy will be conserved, both together. Then momentum should be conserved, charge must be conserved, baryon number must be conserved, lepton number should be conserved, but strangeness will be conserved, must conserve if the reaction is strong interaction. If it is a weak interaction, it is not necessary for the strangeness to conserve. You would have learned these things. Okay, so charge must be conserved. So we'll check for the charge. This is -1. We know proton is +1. K plus is +1. So the charge of omega is conserved. So left side 0, total charge 0. Right side +1 means it must be -1. Then only the total charge after interaction will become equal to 0. So the charge of the omega particle is -1. Then we'll think about the baryon number. K minus is a meson. Baryon number of a meson is 0. You know that. Proton is a baryon. Its baryon number is +1. This is meson. Baryon number 0. So to conserve the baryon number, the omega should have +1. Okay, so this is the answer for part B. Third part, charge is -1, electronic charge, -1 into 1.6 10 to the power -19 Coulomb, or -1 electronic charge, and the baryon number is +1. Okay, that's all. Now part C, the rest mass of the omega baryon is significantly larger than the rest mass of the proton. Discuss how energy and momentum are conserved during this collision. 6-mark question. So first you should say in this interaction, total mass energy must be conserved. So total mass energy means, you know, proton is at rest initially. K minus is moving. So K minus has kinetic energy, right? It has mass. So when we consider total mass energy, we should consider the sum, the addition of its kinetic energy and its mass, but you can't add joule and kilogram. So what we do normally in numerical calculations, we find the equivalent energy of this mass. You know, if the mass of K minus is m, the equivalent energy mc squared. By using that, we can find the initial total mass energy of K minus, that is kinetic energy of K minus plus equivalent energy of rest mass of this K minus. So I can say the initial total mass energy of K minus, I can say initial total mass energy of K minus is kinetic energy of K minus plus the mass of K minus C squared. So this is the initial total mass energy of K minus. Proton is at rest, so it has no kinetic energy, but it has mass. So we need to find its equivalent energy, that is mass of proton, C squared. So this will be the initial total mass energy of K minus and proton, because the reason why am I considering m mass of K minus C square means we need to consider total mass energy. Mass alone will not be conserved in this type of reaction. Reason, you know, mass can be converted to energy according to special theory of relativity, or energy could be used to create new mass. So that's the reason mass alone will not be conserved, energy alone will not be conserved. Total mass energy, that will be conserved. So mass energy of K minus is kinetic energy of K minus plus equivalent energy of rest mass of K minus. Proton has no velocity, it's at rest, so it has no kinetic energy. but its equivalent mass, the equivalent energy of rest mass is mvc square. This must be equal to, now omega is in motion, so it has kinetic energy of omega. Same way, it has mass, so it should have equivalent energy of mass, so m omega c square. Same way, K plus has kinetic energy. After creation, it would have motion, so kinetic energy of K plus mass of K plus c squared. So this is the conservation of total mass energy in this interaction. We had to write this in words. I'll write the answer. The next thing is about the momentum. The total momentum is conserved. So total momentum is conserved means we can explain like this. So proton is at rest, so proton has no momentum, only the K minus is in motion. So the initial total momentum will be same as the momentum of K minus because proton is at rest. After collision, they are creating omega particle and K minus. So they both of them has momentum. At this position, we should consider the omega has momentum along this way. K minus, this is the momentum of omega. This is the momentum of K minus. Like a draw a tangent, you know velocity on a curved path. To find the velocity, we draw a tangent at the point where they are created. So momentum of K plus, K minus is draw a tangent at this point. That is the momentum of K minus. So the resultant of these two momenta, because total momentum is conserved, so resultant of these two momenta must be equal to momentum of K minus. So if I draw a vector diagram, momentum vector diagram for momentum of omega and momentum of K minus, the resultant or the total momentum must be equal to momentum of K minus. So momentum of omega, momentum of K minus must be equal to the initial momentum, K plus must be equal to momentum of K minus. So in this way, total momentum is conserved. In terms of vectors, if I write momentum of K minus is equal to momentum of K plus momentum of omega. You can write this way to conserve the total momentum in terms of vectors. Or you can say like total horizontal component of momentum of omega and K minus. So along x direction, we can say momentum of K minus is equal to momentum of omega cos, or the component cos. You don't have the angle or anything. So momentum of omega in x direction plus momentum of K plus in x direction. Also, when you consider vertically, it has no vertical component initially. So when I consider vertically, 0 is equal to upward direction, momentum of K minus in y direction, minus, because this component is downwards, minus momentum of omega in y direction. Either way, you can write this vector diagram and draw the vector triangle, or you can write this one. Anyway, both are accepted. Okay, question 17. Experiments with muons are taking place at Fermilab in the USA to improve our understanding of the standard model. The muon belongs to the same family of particles as the electron. State how the muon is classified in the standard model. So we can say muon is a fundamental particle. You will get 1 mark, and muon is a lepton, second mark. Okay, B part. A muon can be produced by the decay shown in this nuclear equation. That means the reaction says when negative pion, pi minus, negative pion decays, it produces muon and anti-muon neutrino. Muon and the neutrino, it's created. So state the name of the two other particles involved. So you can say pi minus is negative pion. The other one is the on the right side, that is muon and the neutrino. This is muon and the neutrino, and this is negative pion. You can write that answers. Okay, C part. A website states the rest mass of a muon is 106 mega electron volt over C squared, which is a little over 200 times that of an electron. Deduce whether this statement is correct. Okay, so we know that we can show the mass in terms of mega electron volt over C squared or giga electron volt over C squared, like that. So here the mass of the muon is given as 106 mega electron volt over C squared. So mass of a muon is given as 106 mega electron volt over C squared. That is 106 mega 10 to the power 6 electron volt, 1.6 10 to the power minus 19 over 3 into 10 to the power 8. C means speed of light in vacuum, that is 3 into 10 to the power 8 all its square kilogram. So I can convert this unit to kilogram by substituting the values kilogram. You will get this answer 1.88 10 to the power minus 28 kilogram. So we need to show it's almost 200 times. So divide the mass of muon by mass of electron. Mass of electron is given in the data sheet. So that will be 207. Okay, so you can say statement is correct. That answer you should write, statement is correct. Okay. Now next part, D part, muons are stored in a storage ring at Fermilab. The website describes the ring as having circumference of 44.7 meter and using magnetic field of flux density 1.45 Tesla. The website claims that this enables the storage ring to confine muons with a momentum of 3.10 giga electron volt over C. So D part, first part, explain why the unit giga electron volt over C is a valid unit for momentum. So we can say, we know that momentum is given as, momentum is defined as mass times velocity. So I'll write the answer here. Part D, first part. Momentum equal mass times velocity. So unit of momentum unit of mass, we can give it in terms of giga electron volt over C squared or mega electron volt over C squared. In that format we can give it. So that is unit of mass giga electron volt over C squared, and velocity we can put C, the same unit. C is a notation of speed of light, but we can say into C. So giga electron volt over C. Okay, second part, D part, second part, deduce whether the website claim is correct. So what they are saying, now the website describes the ring as having circumference of 44.7 meter and using a magnetic field of flux density 1.45 Tesla. So the momentum is given as 3.10 giga electron volt over C. So its equivalent value in Newton second is 1.65 10 to the power minus 18. So we need to check whether the statement is correct. So D part, second part, I need to use R equal P over VQ and find the radius. After finding the radius, I'm going to find the circumference. So is it correct? Is it tallying with 44.7? So, you know, if you want to keep a particle in a circular motion in magnetic field, it should have a specific values. R equal P over VQ should be satisfied. So whether we are able to get that value, I'm going to find out. R equal P over VQ. The momentum is given as 1.65 10 to the power minus 18 over the magnetic field is given as 1.45 and the charge is 1.6 10 to the power minus 19. So the radius will be equal to 7.11 meters. So the circumference 2 pi r, 2 pi into 7.11, that is 44.7. So the question also saying the muons are kept in a ring of circumference 44.7. So these values are correct. So correct claim. Okay, question number 17. D part, third part. Stationary muons are unstable and have a mean lifetime of few microseconds. Actually, lifetime, a stationary muon, its lifetime is 2.2, almost 2.2 microsecond. After that, it will become energy. Energy means it will decay into photons. So their lifetime is almost 2.2 microsecond. Based on this, there was a question, January 2021 IAL paper unit 4, question number 14. So I'll explain about this special theory of relativity time dilation in more detail when I discuss January 2021 unit 4 IAL paper question 14. I'll explain more detailed theory regarding time dilation. Not in your syllabus anyway, you don't have relativity, but anyway, those students sometimes ask, so for them I'll explain when I discuss January 2021 paper. So here they are saying stationary muons are unstable and have a mean lifetime of few microseconds. Explain why muons in the ring, so they are in motion, very high speed, they accelerate to very high speed, almost closer to speed of light. So they are moving in a ring and observed have a much greater mean lifetime. So this is the basic idea about this special theory of relativity, time dilation. Say for example, you have two identical clocks, exactly the same identical clocks you have, and they are started with the initial same time, they are adjusted to same time. So the second hand is clicking like 1 second. Here also it will click 1 second. Exactly the identical clocks. Okay, now if you name this identical clock X, this as a Y. Now imagine the clock Y is attached with a moving vehicle or rocket, whatever it is. Imagine a moving vehicle. So behind this clock is now filled, right? And this vehicle is moving at very high speed, almost closer to speed of light. So imagine 0.994 times of speed of light. Very high speed, it's moving. And you are standing closer to this clock X. So clock Y is moving with a vehicle at very high speed. And now your clock is clicking every 1 second. Now what if you observe this clock, earlier both were identical, both click the same time, 1 second is the same. Now if you observe this clock, you will see this clock will slow down. That means there's a relationship. For example, the time taken for a second hand to move through a time t0, if the time is t0, here if it takes t0 time elapsed, in your clock, how much will be the time? That will be t0 over square root of 1 minus v squared over c squared. Not in your syllabus, but I'm just showing it. That means in your clock, or in this clock, which is in motion, T naught is the time taken for the second hand to move, then your clock during the same time will be shown on your clock by this time, where V is the speed of the clock relative to you, C is the speed of light. For example, in this clock, when 1 second passes, say the second hand moves through 1 second, that means T naught is 1 over square root of 1 minus V squared is 0.994 C all the squared over C squared. So when this clock, the clock which is in motion, completes 1 second, your clock will complete 9 seconds. Almost it will be 9.14 seconds. That means when your clock moves 9.14 seconds, then only the moving clock will complete 1 second. That means this clock is running slowly. Not only clock. You know, according to special theory of relativity, the first postulate Einstein made, all the physics principles must be the same in all frame of reference. Frame of reference means, you know, the coordinate systems. Too much for you, but anyway. So that means not only the clock slowing down, all the physics, all the laws should be the same, means even the chemical reactions will slow down. For example, maybe when you are mixing two different chemicals, the outcome might take 5 minutes here, means here it will take much longer time. So the person who is sitting inside, if he make the same chemical reactions, when he mix two chemicals together, for him it will take 5 minutes. You take 5 minutes, here also he will take 5 minutes. But when you observe that, you will measure the time taken for it to happen is longer. Anyway, that's the time dilation. That's called time dilation. So here what happens, the muons are in motion. If the muons are at rest, their lifetime is 2.2 microsecond. But when they are in motion, in their clock, it takes 2.2 microsecond. But when we observe it, imagine a muon is moving in circular path. We are observing the lifetime of the muon. We will measure the time taken by the muon to survive is much more than 2.2 microsecond because it is in motion. For example, if you substitute muon, if it has a clock, can't be, but if the muon carries a clock, its lifetime will be 2.2 microsecond. So substitute here 2.2 microsecond, 2.2 microsecond over square root of 1 minus, if the muon is moving at this speed, 0.994 C over C all the squared. And you are measuring, you are observing the muon, how long it exists, you are observing from the laboratory. Muon is in motion. You will say the muon is surviving not 2.2 microsecond, it's surviving for 20.1 microsecond. So it's decaying after 20 microsecond. That's the way the scientists will measure the lifetime of the muon. Okay, so the answer is a little bit too much for you, but you don't need any of these equations. Just I told, I'll explain more in detail when I discuss the January 2021 question 14. There also you don't need, but I can explain a little more in that one. So here the answer is very simple. You can say that muon is traveling at very high speed, closer to speed of light, 1 mark. Due to relativistic effect, its lifetime will increase, 2nd mark. That's all. Okay, question 18. Faraday's law can be written as the normal standard format minus d phi by dn phi by dt. State the name of n phi. You can say total magnetic flux linkage. Total magnetic flux linkage with a coil. You can say that it's given in Weber. The unit is Weber. So state the name of the term and its units. Weber is the SI unit. Total magnetic flux linkage, 1 mark. Its unit is Weber, 2nd mark. So they give a diagram. The coil of 500 turn and the radius 3 mm is placed between two poles of an electromagnet. The terminals are connected to an AC power supply. So the graph shows how the magnetic field strength, not the magnetic flux, it's a magnetic flux density, B, that is magnetic field strength, varying with time is given as a sine-shaped graph. Determine the maximum EMF across the coil. So the graph is given something like this, the variation of B with time. So it's a sine shape. This is the variation of B. Okay, so we need to find the maximum magnetic flux linkage. So we can say delta phi, so E max, the maximum induced EMF equal to change in flux linkage, rate of change of flux linkage maximum. And we know that phi is equal to VAN. Okay, so this I can say del VAN over del T change maximum. So here the area of cross section A and the number of turns have no change, so I can take it out. So AN delta V over delta T maximum. Okay, so we can find this is time, this is B. So if I have B against T graph, delta B over delta T gives the gradient. You know that if it's the YX graph, delta Y over delta X or dy over dx gives the gradient. So here it gives the gradient of magnetic field strength against time graph. So I need to find the maximum gradient. How can I find it? Keep the ruler like a tangent and move the ruler along the graph where the ruler becomes more vertical. It could be somewhere here, then it's getting horizontal, then it's coming here. So where the ruler becomes more vertical, it could be negative gradient or positive gradient, doesn't matter. Where the ruler becomes more vertical, there draw a tangent to the graph. So I can draw the tangent either here or here on the given graph. So if I draw a gradient here, something like this, if I draw a gradient here, so I can't draw it on the board, but you can draw it on the given grid. So that will be the maximum slope is the dB over dt maximum. So I drew a gradient there. So now I'm going to substitute. I'm going to find the gradient, take two clear points on the tangent, you drew it. So A, you know, pi r squared into 3 into 10 to the power minus 3 all things squared into number of turns 500 into the maximum gradient. I drew a tangent here. So that is the 2 points. I'm taking two clear points, 0.32 minus 0.32 over 0.013 minus 0.007. Solve it, you will get the answer. So that will be 1.51 volt. Okay, the last part of question number 18, that's the last question. Some electric motor designs rely on electromagnetic induction. A laboratory demonstration of the principle of an induction motor is shown. That's a diagram they are giving it, a photograph. An aluminum disc is free to rotate and is initially stationary. A powerful magnet is moved around the disc in the direction of the arrow without touching the disc. So you are moving a magnet, powerful magnet, without touching on a clockwise direction. So along the disc, so this is the axis of the disc. The disc can rotate either clockwise or anti-clockwise. You are moving a magnet without touching, you are moving it like this. So when it is moved, the aluminum disc also moved in the same direction. Explain why. Okay, so first we can simply say the magnetic field or magnetic flux linkage with the disc is changing. So according to rate of change of magnetic flux linkage, there will be induced voltage, because when you are moving it, you can say the magnetic field lines are cut by the aluminum disc, or the flux linkage with the disc is changing, so there will be induced EMF. And you know, aluminum is in a closed path, is providing a closed path, so there will be induced current. Now we should go to the so if there's an induced current, there will be magnetic field. So there will be magnetic field due to the electromagnet. So when there is a current flow on the disk, it will produce a magnetic field. That magnetic field and the magnetic field of the permanent magnet both are going to interact. So there will be catapult effect. There will be force on both the magnet and the disk. Catapult effect. So there will be current flow. That current creates magnetic field. That magnetic field and the magnetic field of the strong magnet, the permanent magnet, going to interact. So there will be force on both the aluminum disc and the permanent magnet. So what happened? Now we need to think about Lenz's law. So Lenz's law says the direction of the induced current is such that to oppose the change in flux or oppose the action. So either way we can explain. Change in flux means, so what happens when the magnet is moved, the flux linkage is changing. So if the disk wants to oppose the change in flux, that means the flux linkage wants to change, means if the disk also rotate with the magnet, there is no change in flux. Say for example, imagine like this, a coil. Imagine a situation, a coil. You are moving a coil through a magnetic field. So there's a uniform magnetic field is here. So coil is moved, and when the coil enters into the magnetic field, the flux linkage with the coil is changing. So there will be induced voltage and there will be induced current. But imagine this magnetic field is created by two Magnador magnets. So if when the coil is just entering, say when the coil has come to this position and the coil is moved at, for example, 0.5 meter per second, when you move the Magnador magnet in the same direction at the same velocity 0.5 meter per second, means relative to magnetic field, the coil is at rest. There is no change in magnetic flux linkage because both are moving in the same direction. Means O-level student might say the coil is not cutting the field line, both are moving at the same velocity, but we can say if both are moving in the same direction, there is no change in magnetic flux linkage, so no induced EMF. So the same way, so when you are moving the magnet, the coil is, the magnetic flux linkage is changing with the aluminum disc. So according to Lenz's law, it will try to oppose, the induced current will try to oppose the change in flux. Means if the disc rotates in the same direction as the magnet, the flux linkage with the disc will become less or will oppose the change in flux linkage. So we can explain that way, or we can think in terms of force. You know, there is induced current. The induced current should oppose the motion of the magnet. Means now both magnetic fields are overlapping. Magnetic field of the electromagnet, the current in the disc, and the magnetic field of the magnet, both are overlapping. So both will have force. So the force acting on the magnet will be opposite to the direction of motion. So if the magnet is moving, this is the magnet. If the magnet is moving this direction, the force will be this direction. The force on the magnet will be such that to oppose the motion of the magnet. So if the force on the magnet is opposite this way, according to Newton's third law, what's the reason for this force? This force on the magnet is given by the electromagnet of the disc. Disc is acting as an electromagnet. So if the magnet is experiencing force this direction, according to Newton's third law, the disc will experience force opposite to this direction. Means this way the disc will experience force, so the disc will move in that direction. Either way we can explain in terms of magnetic flux or in terms of force. Anyway, both will be accepted. So, okay, I hope this discussion is useful to you. So, I'll discuss other papers also. Mostly, I'll discuss January 2021 next. So, if you subscribe my channel, you will get the notification when I upload that video. Okay, bye.